Did she switch out maybe?
We'll be okay. Okay, let's say you take 3 coins. You flip maybe a nickel, then a dime, then a quarter or something, okay? You flip 3 coins. I want you to see how to draw a tree diagram for that. So the way you start with a tree diagram is you start with a dot, and then you figure this is our first flip. You can either get heads on the first flip or tails. So that's flip number 1. Then if you got heads on the first flip, on the second flip you could get heads or tails. Or if you got tails on the first flip, on the second flip you could get heads or tails. So far, this is how you read the tree diagram. You go up the branch. So you could get heads and then heads, or you could get heads and then tails, or you could get tails and then heads, or tails and then tails. So there's like four possible outcomes. So you'll flip the third coin. The third coin could be heads, so you could go heads, 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 or the third coin could be tails, and that's true for each option. You could get heads or tails again. So what this is showing is that you could get heads, 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 tails, heads, tails, heads, heads, tails, tails, or you can go tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. So how many different outcomes do you see up there? If you count the branches, you'll know the outcomes. 8.
8.
Okay. Each time you flip a coin, how many options are there going to be? 2. So when you flip that first coin, there's 2 ways it can land. You flip the second one, 2 ways it can land. Flip the third one, 2 ways it can land. There's 8 outcomes. If they ask you to do a tree diagram, that's what they're looking for. If they ask you to list the sample space, the sample space would look like this. You may or not be asked to do this. Heads, heads, heads would be your first outcome. Heads, heads, tails would be your second one. Heads, tails, heads would be this one. Heads, tails, tails would be the fourth one. Tails, heads, heads would be the next one. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. That's what they mean by the sample space. We list out all the possible outcomes. There's 8 of them. So, what is the probability of getting tails, tails, tails?
1.
Right. There's only one way to get that out of 8 possibilities. So the probability, that's what the P means. Tails, 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 it's 1 out of 8. What's the probability of getting 2 heads?
Exactly 2.
Let's see. There's 2 heads.
3.
There's 2 heads.
Right
1 head. There's 2 heads. 1 head. 1 head. 3 out of 8. There's 3 ways to get 2 heads out of 8 possibilities. What if it says 2 or more heads?
4.
Then you'd also have to include this one with 3 heads. So that would be 4 out of 8. Or a half. Correct. So you got a 50-50 chance of getting 2 or more heads. Last question. If you flip 3 coins and you repeat that process 16,000 times, how many times would you expect to get all tails? Well, what fraction of the time would you get all tails?
1/2.
1/8. Yep, all tails is right here. That's only going to happen 1/8 of the time. So if I do it 16,000 times, I need to figure out what 1/8 of 16,000 is. So take 1/8, it means time, so 1/8 of 16,000 comes out to 2,000 times. Now, is it always going to be exactly 2,000? No, it's going to be close though. What law is that says that the results of your experiment over a large number of trials will get close to the theoretical probability?
Law of large numbers.
Law of large numbers, perfect.